This is Britt Caswell with another example video. In today's video, I'm covering example 2 from lesson 5-2 in the SavvasRealize Algebra 2 textbook. Today's video is how to use properties of exponents to rewrite radicals. Now, y'all, I think they're overcomplicating this a little bit with Savvas. I'm not judging, but just so you know. So for part A here, it says, how can you extend the properties of exponents to derive the property of radicals? When we say derive in math, by the way, oh, come on now. When we say derive in math, all that we're saying is to come up with or to prove the properties of radicals. So what we're doing is we're trying to use our previous knowledge to help us to make new rules for stuff that we may not have seen before. All right, so here in example 2, part A, I want us to remember the power of a words, this is hard to say, power of a product property. I'm going to write that down because Lord knows I won't be able to say that again. Power of a product property. Whew. So the power of a product property, ooh, I did pretty good there, says that if you have a product such as A times B and you raise it to some exponent, I'm going to use the exponent x because I'm not very inventive, you can distribute that x across that multiplication. Okay, and that only works with multiplication. Now remember, what we've been doing in these last two sections has been writing rational expressions, so expressions raised to a fractional power, as roots. So if you remember that a root is really just an exponent. Oh, getting a little too far ahead of myself there. I missed my B, didn't I? So if we can remember that a root is just an exponent, right? So this is the nth root of A times B. I can write it as an exponent, and I can use the power of a product property in order to distribute this exponent across A and B. So I can actually write this as A to the 1 over n times B to the 1 over n. And if I convert that back to radicals, you get the nth root of A times the nth root of B. And that's their entire point here, where really they could have just said, hey, you could just break up that root. Okay, so that's kind of the name of the game here. This also works across division. So for example, if I had the nth root of A over B, I could break that up as the nth root of A over the nth root of B. And that's a really big deal as you guys get into trig. We like that in trigonometry. Alrighty, so now let's go ahead and let's look at this one. So the first thing that I do, y'all, is I actually find the prime factorization of any numbers. So what that means is I'm going to be using a factor tree like we learned in 6th and 7th grade. So I'm taking 16 and I'm saying, what multiplies to make 16? Well, that's 4 and 4. Now 4 can be broken up into 2 times 2. And those are prime numbers, right? They are components that can't be broken up further. So inside this radical, I have 4 2's, and that came from that factor tree, y'all. I also have 5 x's. And I'm showing it to you like this for a certain reason. I know it's a little weird, but I think it'll help you to visualize it. Okay? So I have 4 2's that came from the 16, and I have 5 x's because that came from the x to the 5th. All right, so what I'm doing here is I'm using the index. Okay, remember the index is the little teeny tiny number outside the radical? And I'm using it to tell me how many of a kind I need to pull a number out of the house, out of the radical here. Okay, so what this index is saying is that you need 3 friends to go outside. So let's check it out. So right here, I have 3 2's. So as a unit, they come outside. What I'm really doing here is I'm taking the cube root of 2 to the 3rd, and they cancel out, leaving you with a 2. That's why they come out like that. But that's a lot to put in your head on top of all this stuff. I also have 3 x's here. So I'm going to pull an x out. Mind you, I'm not pulling out x cubed, because what I'm doing is I'm taking the cube root of x cubed. And those 3's, they cancel out, leaving you with x. So that's why I'm not putting any powers on these, okay? Now I only have 1 2 left, and I have 2 x's left. So those guys can't go anywhere. All right, they're stuck inside playing World of Warcraft. So these numbers that are left in the house, I kind of recongeal them back together, okay? So the 2 is there, and it's being multiplied times x times x. So x times x is x squared. And that is my simplified form. So what we do is we refer to this as the reduced radical form. And that's just because we took everything out of the radical sign that we can. So there's the phrasing for that. Kind of cool. I actually really like doing these because it feels like I'm playing a game of Go Fish or something. Okay, so now let's try this again. So I have the 4th root of 81, a to the 8th, b to the 5th. So I'm not going to list everything off, but I am going to break apart that 81. Okay, 81 is 9 times 9. And those 9's, you betcha, they turn into a bunch of 3's. So what I really have is I have the 4th root of 3 times 3 times 3 times 3, or you can call it 3 to the 4th, I don't care. A to the 8th, b to the 5th. And so again, I am searching for any sets of 4 that I can, okay? So here I have 4 3's, so I can pull a 3 out of the radical. In terms of the a's, there's really 2 sets of 4 here, right? Because there's 8 of them. So I'm pulling out an a and an a. I'm doing that twice because I can get 4 a's each time. Should cross out my a's. So I took all those a's. There aren't any left, right? Now the b's, there's 5 b's. So I'm going to use 4 of them to take a b out of the house. But still inside this radical, still inside this house, I still have 1 of them. So there's 4 of the b's, and then there's 1 left here. Because that's like b to the 4th times b, okay? And then I'm going to go ahead and stack those a's up. And there it is. Alrighty, so let's go ahead and let's try one last one. So again, I'm going to start by breaking up the coefficient there, the 125. I like to think about money whenever I see things ending in 25. If I had 5 quarters, I'd have $1.25. And I know that 25 times 25 is 5. Okay, so another way to write this problem, I have the cube root of x to the fourth divided by x. Do you see those x's? We don't like having multiple bases that are the same letter, right? And so I'm going to be using that quotient property to just combine those. So that is x to the fourth minus 1, because this is x to the first down here. So there's x to the third up there, okay? And then I have a y squared. And down below in the fraction, this is where that factor tree comes into account. That 125 is 5 cubed. So now let's start canceling stuff out. So I have 3 of a kind for my x's, so I'm going to pull an x out of the radical. But I only have 2 of a kind of the y's. So the y's are going to stay inside the cube root, like that. And then down below my fraction, I have 5 to the third. So I already have 3 5's, so I'm going to remove the 5 as well. So there's that reduced form of it. But there we have it. That's how we're rewriting radicals. Until next time.